The oldest galaxy ever confirmed by astronomy finished forming less than 300 million years after the Big Bang. The light reaching us from it traveled for more than 13 billion years before hitting the mirror of a telescope. And here's the strange part. Today, that galaxy is moving away from us faster than light itself can travel, dragged along by the expansion of space. Astronomers named it Jade's GS Zeph-14 Zero, and it still holds, as of right now, the most extreme record ever documented by science. To put the scale in perspective, Earth's oldest fossils are less than 4 billion years old. This galaxy already existed billions of years before that, before our planet, before our sun, before anything we'd call history. So how do we even see something that old? Because looking into deep space is literally looking into the past. If the entire history of the universe fit into a single year, this galaxy formed in the first days of January. We as a species only showed up in the last second of December 31st. But that's just the starting point. What comes next completely changes how you think about what a galaxy can be. The most common shape you'll find in the night sky is one you already recognize: spiral. Ours, the Milky Way, is one of them. Its arms packed with stars spinning around a dense center. And it spins slowly from our point of view. The entire solar system takes about 230 million years to complete a single orbit around the galactic core. The last time we were in this exact position, dinosaurs didn't even exist yet. Some spirals carry a straight bar of stars cutting through the center, like an axis running through the disk, and that structure is exactly what funnels gas inward to feed the core. It's an elegant shape, almost too orderly for a universe that, as you're about to see, doesn't stay orderly for long. Because there are galaxies that abandon that order completely. Giant ellipticals have no arms, no disk, just a massive, tightly packed cloud of old stars, nearly all of them born billions of years ago. One of the largest ever cataloged, IC 1101, has diameter estimates reaching into the millions of light years, dozens of times larger than our entire galaxy. If you could drop the Milky Way inside it, there would be plenty of empty space left around the edges. Ellipticals like this are usually the end result of repeated mergers between smaller galaxies over billions of years, and that's already a hint of what's coming. That's where the scale shifts axis entirely. Dwarf galaxies are small, sometimes holding only a few million stars compared to the hundreds of billions in the Milky Way. But what makes this type dangerous isn't size, it's proximity. The Sagittarius dwarf galaxy is being slowly torn apart by our own galaxy's gravity right now. While you're reading this, its remains already form a stream of stars stretching across the Milky Way's sky. If you lived on a planet inside it, you'd watch your entire galaxy dissolve overhead, star by star, over millions of years. And that's just a preview of what a gravitational collision can do. Before we go on, if you haven't subscribed to the channel yet, now's the moment. Hit subscribe, because what comes next completely changes the scale of what you thought cosmic collisions looked like. Proof of that is what's left behind after two galaxies pass straight through each other. The Cartwheel Galaxy was born exactly that way. A smaller galaxy punched right through the middle of a spiral. Like a stone thrown through a still pond, the shockwave pushed gas and dust outward into a ring, and that ring turned into a star factory, spawning billions of stars in a period that's remarkably short on a cosmic timescale. What's left today looks less like an ordinary galaxy and more like a gravitational scar that's still glowing. And scars like that carry consequences that last far longer. Starburst galaxies push that star production to a level that's barely sustainable. The Cigar Galaxy forms new stars 10 times faster than our entire galaxy combined. That means stellar winds violent enough to blast gas straight out of the galactic disk, forming visible plumes that stretch for thousands of light years, as if the galaxy itself were breathing fire. It's a pace of star formation that simply can't last. Sooner or later, the fuel runs out. And so far, we've only been talking about stars. Seyfert galaxies have a core so bright it rivals the combined light of the entire rest of the galaxy, despite occupying a tiny fraction of the space. That absurd brightness comes from a supermassive black hole devouring matter at the center. heating it to extreme temperatures right before it disappears. Roughly 1 in every 10 galaxies in the nearby universe falls into this category, which means that when you look up at the sky, there's a good chance you've already seen one without knowing it. But Seyfert is only the first step of active cores. Quasars push this phenomenon to its extreme. They're the most luminous objects ever observed in the universe, capable of outshining an entire galaxy of hundreds of billions of stars combined, all packed into a region smaller than our solar system. The most distant quasars we know of existed when the universe was less than 1 billion years old, which means supermassive black holes were already active long before our models predicted they should be. And if one of those sat where the sun is today, the radiation alone would have sterilized any chance of life in the solar system before Earth even finished forming. There's an even more direct version of that nightmare: blazars. A blazar is essentially a quasar with one extra detail. The jet of particles fired out by the central black hole happens to point almost straight at you. Those particles travel at a fraction of the speed of light, and the beam can carry more energy than the entire stellar output of an ordinary galaxy. If a blazar were pointed at Earth from a relatively close distance, we wouldn't even need to understand the physics to feel the effect. The radiation alone would be enough. After cores that devour matter, the next stage is what happens when entire galaxies devour each other. The antennae galaxies are two spirals mid-merger, twisted by tidal forces into long streams of stars, stretching out like arms pulled apart by each other's gravity. This exact process is already underway with our own galaxy. In about 4 billion years, the Milky Way will collide with Andromeda, and the two will merge into a single giant elliptical galaxy. Individual stars will barely collide with each other. The space between them is simply too vast for that. But the structure, the shape, everything we currently call our galaxy will cease to exist. And if the timescales already feel overwhelming, the next type challenges our very ability to see. Ultra-diffuse galaxies are the size of the Milky Way, but contain less than 1% of its stars. Dragonfly 44 is one example. An object so faint it nearly vanishes into the dark background of space, held together not by the gravity of its handful of visible stars, but by an enormous amount of dark matter, the substance that makes up most of the universe's mass and that no one has ever directly detected. It's an entire galaxy hiding, almost literally, in the dark. And if something like that can exist nearly invisible, scientists are already considering one step further: fully dark galaxies. Hypothetical structures, dominated almost entirely by dark matter, without enough stars to shine in any detectable way. Candidates for this phenomenon have already been spotted indirectly, through the gravitational effect they have on surrounding gas, but none has ever been confirmed outright. These would be real galaxies with real mass, real gravity, that simply never turn on. And it's exactly at the line between confirmed and hypothetical that this list ends. The newest telescopes have already found galaxies in the very early universe, less than 700 million years old, that should be small and disorganized according to current models, but instead show up massive, mature, and full of old stars, as if they'd grown up far too fast for the time they had. Some of these objects appear so massive that they call into question part of what we thought we knew about how the earliest galaxies, including that same JADES GS Z14-0 from the start of this list, managed to form so early in the universe's history. Nobody can fully explain how that's possible yet. And maybe that's the most unsettling part of studying the cosmos. The deeper telescopes look, the less predictable the beginning of everything seems to be. If this kind of mystery got under your skin, drop a like on this video, subscribe to the channel to keep up with what comes next, and let me know in the comments which one of these galaxy types caught your attention the most. I really want to hear it.